So here is another question on projectile motion with horizontal projection. It is given that a boy throws a stone trying to hit a target, okay, with a horizontal velocity of 500 meter per second, and which is at a distance of 50 meter. It means the target is at a horizontal distance of 50 meter away from the boy. How high above the target should the boy stand so that the stone hits the target? Okay, this is target here, not bottle, it's target, because nothing is mentioned, simply a target. So, and here we have to take acceleration due to gravity, small g is equal to 10 meter per second square. Okay, so let us try to understand the situation. Here, let's say we have a target. Okay, this is the target, and we have, let's say, a boy here standing here. Why it is given how high above the target should the boy stand so that the stone hits the target? Why it is like this? When the boy hits the stone, hits the target by throwing a stone only with horizontal velocity, in that case it will undergo a projectile motion like this. So in that case, if the boy stands at the same level as the target, okay, on the same plane, then the stone will most likely miss the target by a certain margin. So for this, what the situation should be is that the boy should stand at a level higher than the target. Okay, he should stand a bit higher. Okay, only then the stone will hit the target. So here we have to calculate how high should the boy stand so that the stone will hit the target. Okay, that is our objective. So here we have to calculate this height. Okay, this height from this level. This is the ground level and this is the point where the boy is standing. We have to calculate this height so that the stone will exactly hit the target. So here it has been given the horizontal velocity is how much? This is equal to 500 meter per second. So as it is horizontal, we can write it as ux, okay, x component of the initial velocity. Then the horizontal distance between the boy and the target, that is equal to 50 meter. So this horizontal distance, we can call it Sx, that is equal to 50 meter in between the boy and the target. Okay, other things, so the acceleration due to gravity, it is acting downwards. So vertical direction Ay is equal to plus g, which is equal to plus 10 meter per second square, because here specifically it has been given to take acceleration due to gravity 10 meter per second square. Okay, so now simply we have to use this particular equation of motion, that is equal to S is equal to ut plus half at square, and we have to resolve it into two components, because in motion in a plane or projectile motion, both x and y components are taken into consideration separately, they are analyzed separately. So first, Sx is equal to uxt plus 1/2 ax t square. Here there is no acceleration component along the horizontal direction. So simply AX is equal to 0 meter per second square. Okay, ux is this much. We have to calculate the time, okay, or the time of flight. So we'll simply put the values, that is 50 is equal to ux, which is equal to 500 into t. That implies t is equal to 50 by 500 equal to 1 by 10, which is equal to 0.1 second. Okay, this is the time of flight basically. Okay, this time interval which we calculated, that is the time of flight, because this is the time instant for which the stone was in the air, and we calculated it using the horizontal component of this equation. Okay, this time of flight is 0.1 second. Now we will use the second component, which is the y component. So here we have to calculate this height. This height is nothing but the net vertical displacement, SY, of the stone, the net vertical displacement, SY. And this distance between the stone and the target, that was the horizontal range, that was the net displacement in the horizontal or x direction. So here we'll be using the equation SY is equal to UIT plus 1/2 AY t square. Here only horizontal velocity is there, no vertical component is there. So Uy is equal to 0 meter per second. So as Uy is 0, so this whole part will become 0. So we'll only have 1/2 AY t square. AY is G plus G. So it is equal to 1/2 G t square. So we'll replace t with time of flight. So we'll have the result equal to H equal to 1/2 into 10, that is G, into time of flight TF, which is equal to 0.1 square. And that is equal to 5 into 0.1 square. So that will be equal to 0.05 meter or 5 centimeter. So this is the height above the target the boy should stand so that the stone will exactly hit the target. This is the thing which was asked in this question, and we calculated it. So again, always be clear about which equation of motion is applicable, and in two-dimensional motion always analyze the x and y components separately. Okay, always analyze them separately. Okay, this is the x component analysis and this is the y component analysis. And the parameters you should assign carefully. You should see what is the component along x, what is the component along y for velocity, acceleration and displacement. Okay, so here we calculated the height above the target, which is equal to 0.05 meter. Okay. So here is another question on projectile motion. So here it is given that a man runs across the rooftop of a building and jumps horizontally with the hope of landing on the rooftop of the next adjacent building. I mean, at a certain distance away, which is of a lower height than the first. If his velocity is 9 meter per second, the distance between the two buildings is 10 meter and the height difference between the two buildings is 9 meter, will the man be able to make the jump and land on the next building safely? Okay, so let us try to understand this whole situation. So here we have two buildings. This is building number 1 and we have building number 2. The height difference between the two buildings, that is 9 meters. The man is making the jump with a horizontal velocity of 9 meter per second and the distance between the two buildings, that is 10 meter. Okay, this is the distance between the two buildings. So here what we want to know is how much horizontal distance does the man cover with this horizontal velocity. We want to know that. If the horizontal distance covered by the man is greater than the separation distance between the two buildings, that is 10 meter, then he will land here safely, no problem. But if it is lesser than 10 meters, then he will simply fall down on the ground. Okay, so here we have to calculate Sx. So some parameters which we have to assign. This is the horizontal component ux. Uy is 0 because there is no mention of any vertical velocity component. Acceleration along the x-axis, that is 0 meter per second square. No mention of any acceleration or deceleration along the horizontal axis. Gravity is acting downwards. For the downward motion of the object, it is supporting it in the same direction, so it is plus g. Now here the net vertical displacement of the man, if he makes this jump safely, then that is Sy is the height difference of the two buildings. We are assuming that he is making the jump safely. So Sy is equal to 9 meter, that much, the height difference between the two buildings. So we will use the equation Sy is equal to Uyt plus 1/2 Ay t square. That implies we'll substitute Sy with 9, Uy is 0, so this whole thing will become 0. That is equal to Ay is equal to plus g, which is equal to 10 meter per second square. So this becomes 1/2 into 10 into t square. That implies t is equal to 2 into 9/10 root over. This is nothing but the time of flight. 2 height difference by g, time of flight. So this is coming around 18/10, so it will be around, it's coming 1.34 seconds. Okay, this is the time of flight of the man as he jumps from one building to the other. Now the horizontal velocity of the man is how much? Ux is equal to 9 meter per second. So we want to know how much horizontal distance it covers in this time of flight. So it is simply equal to horizontal velocity into time of flight, which is equal to 9 meter per second into 1.34 seconds. So it is coming around 12.8 0.06 meters. So this horizontal distance covered by the man with this horizontal velocity is greater than the separation distance or separation gap of the buildings, that is 10 meter. So it means that he will safely land on the rooftop of the next building. Okay, he will safely land on the next building. So he is able to make the jump, but it's a foolish thing to do again, to jump from one building to another, but still, as the question is given, so as per the question, okay, so as per the question, the man is safely able to make the jump because the horizontal distance covered with this horizontal initial velocity, that is equal to 12.06, which is greater than the separation distance of the two buildings. Okay, so he will be able to make the jump.